Hello everybody, thank you for clicking in on my video. My name is Egbert and this is my Math 355 Calculus for Biology and Medicine final project. The topic I will be discussing today is the growth and the growth rate of a fetus and how calculus is used to understand this topic. But before I get into the complex math behind the growth and the growth rate of the fetus, let me first explain what this topic is. As an introductory, during pregnancy, the baby yet to be born is known as the fetus. The fetus is constantly growing during this pregnancy process, and after around 9 to 10 months, the fetus is born and is now considered a baby rather than a fetus. When this baby is born, its height is measured from head to toe, as are we to this day. But during the gestational ages, which are the ages of the fetus during pregnancy, which are measured in weeks, the babies who are in the womb have their legs usually bent, making it harder to measure their height. Instead of measuring from head to toe to understand the height and growth rate of a fetus, we use the height of the baby starting from their crown, also known as the top of their head, to their rump, or in other terms, their butt. This length measurement is known as the crown rump length, or otherwise known as CRL, which is how I'll be referring to it in the video, and is measured in millimeters. As you can see from this image from the Name website titled Estimations of Gestational Age, the red line represents the CRL of a fetus during differential gestational ages. Because the fetus is constantly growing, measuring the CRL in gestational age increments can begin to reveal the growth rate of a baby. However, this is only the start of how math is used to understand this topic. And now it is time to get into the complex math and where it originates from. Calculus has many applications, one of which is growth. Calculus can be used to measure growth and also model graphs based on this growth. One form of a growth equation is the growth differential equation created by Benjamin Gompertz in 1825. His equation and models were originally intended to represent the rate at which mortality increased as people got older, but has been modified to represent the model the model of biological aging. When it comes to the CRL of a fetus, Gompertz's growth differential equation is the best equation to understand and predict the length of a fetus during gestational ages. And then I have a citation there, which I'll mention at the end of this video. This differential equation, looks like dp divided by dt equals p times, in parentheses, a minus b times the natural log of p. This equation represents the growth rate, while the equation in the graph to the right would be an interpretation of the integral or antiderivative of the differential equation that best fit this study. This means that this graph is showing the CRL of the fetus during different gestational ages, which is why it is always increasing, because the fetus will never shrink. If there was a graph for the differential equation, it would show the rate of which the CRL is growing during different gestational ages. Rather than the actual size, this graph would loosely resemble the bell curve on the right, because the fetus during the first 12 weeks grows at a slow rate. By the 12th week, it grows at a quicker rate, reaching its peak as the bell does, somewhere near the middle, and would eventually slow down again near the 32nd week and before the baby is born. Both graphs would never be negative, because that would mean either the baby was shrinking or that the baby's height is negative number, which is not possible. This math is very complex and can be very hard to understand, but it is important to not cut corners with math, or else you'll get wrong data results and misinformations. For example, take a look at these two graphs, which came from the academic article titled Mathematical Modeling of the Growth of Human Fetus Anatomical Structures. On the left side, we have a linear model, and on the right side, we have Gompertz's model. The linear straight line model represents linear growth, which would have a constant rate of change. It is a straight line trying to represent the average linear growth of the CRL of a fetus. While this is easier to understand, the growth and the growth rate of the fetus is not linear. The fetus is constantly growing, but the rate at which it is growing is inconsistent, causing bends and curves within the graph, which the Gompertz equation more accurately represents. When you look at the Gompertz model, you see that it accounts for the slow growth rates during the beginning and ends of the gestational ages. This is an example of why Gompertz's model is one of the best ways to model the growth of a fetus. And this is also an example of how calculus and advanced calculus is used to understand the growth of the fetus. While this topic can be very hard to understand but still quite interesting, there is an importance to understanding this topic. One of the reasons why it is important is because by knowing the crown rump length can help determine the gestational age. In other terms, this means that people can know about how long they have been pregnant for when they do not know when the conception happened. Another reason why it is important is because it can show if a baby is growing healthily. It is not the end of the world if a baby does not fit perfectly in the Gompers model, because the Gompers model is not a perfect example of growth because it represents an average and not every single baby in the world or every single fetus in the world. But the model can still help represent the average of a fetus growth. And by comparing the average fetus growth to the CRL recorded during scans, you can then determine if the baby is growing healthily and if the baby growth rate is also as healthy. Thank you for listening in on my video. All the websites and sources I use to understand this topic will be linked down below in the description. Thank you for listening.